Another example for class 12. I'm going to walk through Shigley's example 11-5 here. So a ball bearing is run at 4 piecewise continuous steady loads. That means that like they're doing these, this is the amount of time that the thing is, so 10% of the time it's going to be running at 2,000 RPM. 10% of the time, 3,000 RPM. But at 10%, 2,000 RPM at this amount of load. For whatever reason, they decided to do it in pounds. Would have been nice if they did it in kilonewtons, but whatever. 10% of the time, 3,000 RPM, doing it for 300 pounds. 30% of the time at 3,000 RPM, but 750 pounds. And 50% of the time, 2,400 RPM at 375 pounds, right? So you get the idea. There's 4 different loading conditions, 4 different things. And also we could have and by the way, we have 4 different application factors, right? So sometimes it's a little bit more like tapioca, sometimes it's a little bit more like crushing rocks, right? So these are all things that we know that that the piece of equipment has to act this way, right? So it's maybe this happens during the thing's commute, right? Every day, and it goes over the same potholes and that kind of thing. So it just occurs over and over and over again. So or when the shifts change, right? As the different people operating this machinery operated differently throughout the different shifts during the day. For some reason, we have different loading scenarios here. So what we could do is, and if we don't know the amount of actually time, and we only know the percentages of the thing and the speeds and the loads and that kind of thing. And by the way, this is kind of funny. I accidentally, I think some of these things are given. Yeah. These are actually stuff. I forgot about that. That like if this was a problem right here, they would just give you this information, right? That you were, this is the radial load and this is the axial load, and then this is the and then we would find the equivalent right here, right? So. So I should have fixed this before. So these are things that you would have known, right? That you had an axial load onto the thing, right? So just like what we did in the last class, you would go through this process right here and find what the equivalent load was going to be. 794, 626, and 878. Right here, and then 668 right there, right? So then you would take this and you would just multiply these two things by each other, right? So I think that's true, right? Is that true? Yeah. Another thing that we would do right here. So these are all just us trying to keep track of stuff right here. Yeah, and they just said 1, 2, 5. So all of these are given. 1 and 2. Columns 1 and 2 are known, and 5 to 8. So all the way through here are given. So what we find is we want to multiply the fraction of the time times this right here. So we go 200 300 900 and 1200. Should be able to do that in my head. Add these all up and we get 2600 right here. So we could say, and by the way, you notice that these all equal 1, right? If you add all those up together right there. So now we take this and divide it by that right there, right? So what we end up finding is we get a percentage, but 0.077, right? So that's divided by this. And this right here is that divided by that. Yes, that's true. Yes, okay. And then here, 346, that divided by this. And by the way, if you added all these up, you would see that they were to 1 right here. Well, they should be equal to 1. All right, so the big idea is that we're going to use equation 11-13 here. And we're going to say that the equivalent is equal to summation, I guess I made that a little bit more fancier, f of this right here. Oh, and these are the equivalent ones. That's why we have the e in there. Okay, I got you. Raised to the a, all to the 1 over a. So we can find the equivalent is 0.077 times 873 cubed, right, because they're all to the a, plus 0.115 795 cubed plus 0.346 966 cubed plus 0.462 835 cubed, all to the 1/3. You do that and we get F. This is the equivalent amount of constant force that was going through here. So you could actually kind of almost eyeball this to some extent when looking at here. You can kind of see, but this is now what we've done is we've systematically tried to find what an equivalent force is going to be, and then that's what we would use, and I would turn that into kilonewtons, and that's what we would use for go into the catalog, right? So we want to go to the catalog now, and before we go to the catalog, we need to adjust this for the amount of hours that we were going to be doing for the thing. So yeah.